Hello, everyone, and welcome. Today, we're going to start a really fascinating chapter from your science syllabus. It's called The Human Eye and the Colorful World. We're going to explore the incredible science behind how we see everything around us. So, let's just begin by thinking about a few things that we see almost every single day, but maybe we don't always stop to think about how we see them. For example, I'm sure you've seen a rainbow, but have you ever really wondered, how is my eye able to see all those beautiful, vivid colors? From the violet all the way to the red, arranged so perfectly in the sky. How does that happen? Or let's think about something you're doing right this moment. How are you able to read the words on this screen? What is it that allows your eyes to focus and make sense of all these small letters? And what about distance? You see, you can focus on this screen, which is quite close to you, and then in the very next moment, you can look out of your window and see a friend waving from far, far away. How does your vision adjust so quickly, so seamlessly? Well, the answer to all of these questions, seeing rainbows, reading a book, seeing things near and far, it all comes down to one absolutely incredible optical instrument that every single one of us has. And that instrument is, of course, the human eye. So in this chapter, we're going to break down how this amazing organ works and how it lets us experience this beautiful, colorful world of ours. So what's our plan? Where are we heading in this chapter? Let's just take a quick look at the journey we'll be taking together. First, we'll understand the eye itself, how it functions. Then, we'll talk about common problems with vision and how spectacles help correct them. After that, we'll explore some beautiful things we see in nature, like how rainbows are formed, why the sky looks blue, and what really makes the stars twinkle. Okay, let's begin with the first part of our journey. We're going to understand the eye itself, our own personal window to the world. A really good way to think about the eye is to compare it to a camera. Light enters our eye just like it enters a camera. Then there's a lens inside that focuses the light, and it forms a sharp image on a light-sensitive screen at the back, which we call the retina. And this is where the eye gets really, really clever. It has a special feature called the power of accommodation. You can think of it like an autofocus function in a camera. It's this amazing ability of our eye lens to actually change its shape, and this allows us to see things that are up close and things that are far away almost instantly. But just like any complex instrument, sometimes our eyes can need a little bit of help. And that brings us to the next topic, common defects of vision and how we can correct them. We will be looking at 3 very common refractive defects. The first is myopia, which you might know as nearsightedness. Then there's hypermetropia, or farsightedness. And finally, presbyopia, which is something that often happens as people get older. We'll understand what causes them and see how using the right kind of lenses can fix these problems. All right, so now that we've seen how the eye focuses light, let's explore something really beautiful, how it sees the whole spectrum of colors all around us. And you know what? It often starts with just a single ray of white light. This image here shows a very important idea called dispersion. When white light, like the light from the sun, passes through a glass prism, it actually splits into a beautiful band of 7 different colors. You can see right here how the light bends and separates. Now, this band of colors has a special name. It's called a spectrum. And this simple acronym, VIBE BGOY, helps us remember the order of the colors: violet, indigo, blue, green, yellow, orange, and red. And understanding this process is actually the secret to figuring out how a rainbow is formed in the sky. For the final part of our journey, we are going to look up, towards the sky. We'll use everything we've learned about light to understand some of the beautiful things that happen in our atmosphere. So, have you ever looked at the night sky and wondered why the stars seem to twinkle but the planets don't? Well, the twinkling doesn't actually come from the star itself. It's because the starlight has to travel through all the different, constantly moving layers of the Earth's atmosphere. This makes the light bend and shimmer, and that's what we see as twinkling. This effect is called atmospheric refraction. And of course, we will answer that age-old question, why is the sky blue? The answer lies in another fascinating property of light called scattering. We're going to learn how tiny little particles in our atmosphere scatter the sunlight and give the sky its beautiful blue color. Okay, so before we finish this introduction, I just want to give you a couple of small tips on how to approach this chapter so you can get the most out of it. Now, I know that for many students, the moment you hear the word numericals or sums, you get a little bit worried. And yes, this chapter does have some numericals. But please do not worry about them. The numerical problems in this chapter are mostly about calculating the power of the lenses needed to correct vision defects. And I promise you, if you first focus on really understanding the concepts, what is myopia, what is hypermetropia, the calculations will become very, very simple and logical. We will practice them together step by step. So, the most important thing to remember as we go through this chapter is this. Your goal is not just to memorize definitions and formulas. Instead, your goal should be to truly understand why things happen the way they do. This chapter is such a beautiful mix of biology and physics. It connects things like light and lenses to the world that you see with your own eyes every day. So, are you ready to begin this journey? Let's go and explore the human eye and our colorful world together.